Welcome. Today we will see another examples of linearization of operating curves. Up till now we have studied two examples. Today again we will see another examples so that there will not be any problem to you. Therefore today we will see example number 3. Critical operating curves for DC motors are shown in figure. These curves are for torque T versus speed N for constant value of voltage V applied to a motor. These curves are the plot of function N is equal to function of torque and voltage E. That is, speed is a function of torque and voltage. Effect a linear approximation for speed. Evaluate the partial derivatives in the approximation, that is at Ti is equal to 2 and Ei is equal to 20. Ti means constant torque is equal to 2 and Ei means constant voltage is equal to 20. Therefore, these are the curves they have provided in the problem. On y-axis torque is there, values are 1, 2, 3. On x-axis speed is there, values are 1000, 2000 and 3000. And due to interaction of the torque and speed, there is a change in voltage, that is E is equal to 15, E is equal to 20 and E is equal to 25. Therefore, these are the curves given and this is the problem. Therefore, we have to find out the linear approximation. Therefore, next solution. Again, we have to draw the curve torque versus speed and their interaction is nothing but voltage. Therefore, here given function is N is equal to function of T and E, that is speed is a function of torque and voltage. Therefore, generalized linear equation is small n is equal to C1 into small t plus C2 into small e, equation 1. Therefore, again we have to draw the curves. Now, we have to find out values of C1 and C2 from equation 1, that is n is equal to C1t plus C2e. Therefore, C1 is equal to dou n by dou t when E is equal to constant, which is equal to delta n divided by delta t when E is equal to constant or mean value of the voltage. Now, what is the mean value of the voltage? This E is equal to 20. This is the mean value of the voltage. Therefore, along this line BC, we have to find out delta t and delta n. Therefore, what is delta n? We will take any 2 points. Therefore, delta n is equal to delta n is given by, that is C1 is equal to NB minus NC divided by TB minus TC, which is equal to, what is NB? NB is equal to 1000 minus NC is equal to 3000 divided by TB is equal to 3 and TC is equal to 1. Therefore, 1000 minus 3000 divided by 3 minus 1 is equal to minus 1000. This is the value of C1. Now, we will find out value of C2. Therefore, C2 is given by dou n by dou e when T is equal to constant. Therefore, delta n divided by delta E when T is equal to constant. Now, what is constant value of T or mean value of T? This is torque T is equal to 2. This is the mean value of the T. Therefore, this horizontal line DE, we will take it as constant and along this line we will find out delta n and delta E. Therefore, C2 is equal to delta n is equal to ND minus NE divided by ED minus EE, ED minus EE, which is equal to ND is equal to 1000 minus 3000 divided by ED is equal to 15 and EE is equal to 25. Therefore 1000 minus 3000 divided by 15 minus 25 is equal to 200. Therefore we will substitute value of C1 and C2 in equation 1. Therefore equation 1 becomes N is equal to minus 1000 T plus 200 E, equation 2. Therefore now N approximate is equal to Ni plus small n. Now what is Ni? Ni is nothing but mean value of the speed. Therefore N approximate is equal to 2000 minus 1000 plus 200 E. From graph we have got this N mean is equal to 2000. Therefore next, now example 4. We have seen example 3, now example 4. The operating curve for the DC motor used to control the position of robot as shown in figure, where T is the motor torque, N is the speed and V is applied voltage. The reference operating point is Ni is equal to 1000 and Ti is equal to 50. Determine linearized equation of operation for the change in torque at the reference point. The net torque available for the acceleration of robot is T minus TL is equal to J into dN by dt, where TL is equal to load torque, J is equal to 0.01. Determine the differential equation relating the output N to input voltage V and load torque TL. What is the time constant and system gain? Therefore they have told us to determine differential equation relating the output N to input voltage V and load torque TL, and they have also told us to calculate time constant tau and system gain K. Therefore this is the problem. They have provided us the curves. Therefore these are the curves. On y-axis torque is there, on x-axis speed is there. Value of the torques are 50, 100, 150. Value of the speeds are 0, 1000, 2000. Value of the voltages are V is equal to 10, V is equal to 20, V is equal to 30, and they have given us this point A as the reference point. Therefore now we will calculate the values. Therefore solution to determine T approximate, time constant tau and system gain K. Here the non-linear function is, that is T is a function of NV. Therefore the generalized linear equation form is small t is equal to C1n plus C2v, equation 1. Therefore we will find out values of C1 and C2 from the curves. Therefore once again we have to draw the curves. Therefore these are the curves, it is provided in the problem. Therefore what is our equation 1? T is equal to C1n plus C2v. Therefore we will find out first of all C1. C1 is equal to dou t by dou n when V is equal to constant, which is equal to delta t upon delta n when V is equal to constant. Therefore what is V? Constant value of V. Constant value of V is nothing but this mean value of the V, that is V is equal to 20. Therefore along this line BC we will find out delta t and delta n. Therefore C1 is equal to TB minus TC divided by NB minus NC, which is equal to, what is TB? TB is equal to 100 and TC is equal to 0. What is NB? NB is equal to 0. What is NC? NC is equal to 2000. Therefore substituting the values, which is equal to 100 minus 0 divided by 0 minus 2000 is equal to minus 0.05. Therefore C1 is equal to minus 0.05. Now we will find out value of C2. C2 is equal to dou t by dou v when n is equal to constant, which is equal to delta t upon delta v when n is equal to constant. What is n is equal to constant or mean speed? This is 1000. 1000 is nothing but mean speed or constant speed. Therefore, along this vertical line DE, we will find out delta t and delta v. Therefore, C2 is equal to TD minus TE divided by VD minus VE, which is equal to, what is TD? TD is equal to 100, TE is equal to 0. What is VD? VD is equal to 30, line passing from point D, that is V is equal to 30. VE is equal to 10. Therefore, C2 is equal to 100 minus 0 divided by 30 minus 10 is equal to 5. Therefore, substituting the values of C1 and C2 in equation 1. Therefore, what is our equation 1? Small t is equal to C1n plus C2v. Therefore, what is small t is equal to minus 0.05n plus 5v, equation 2. Now, they have given us one equation, that is this. First of all, we will find out approximate value of t. Therefore, t approximate is equal to capital Ti plus small t. Therefore, t approximate is equal to, what is Ti? Ti is equal to 50 from the given data or from the graph. Therefore, 50 minus 0.05n plus 5v, equation 3. Now, they have given us this equation in the problem. T minus TL is equal to J into dN by dt. Therefore, T minus TL is equal to, what is the value of J? They have given 0.01. Therefore, T minus TL is equal to 0.01. D by dt means capital D and N here. Therefore, dN. Therefore, small t is equal to 0.01 dN plus TL. This TL we have taken on this side. Now, this is equation 4. Now, what we will do? We will compare equation 2 and equation 4. Because equation 2 is t is equal to minus 0.05n plus 5v and equation 4 is equal to small t is equal to 0.01 dN plus TL. Therefore, comparing equations 2 with equation 4, what is our equation 2? This is our equation 2. Small t is equal to minus 0.05n plus 5v, equation 2. And equation 4, small t is equal to 0.01 dN plus TL. Therefore, comparing these two equations, we have minus 0.05n plus 5v is equal to 0.01 dN plus TL. Therefore, taking terms related to n on one side, therefore 5v minus TL is equal to 0.01 dN plus 0.05n. Therefore, 5v minus TL is equal to n we have taken common from this, n into bracket 0.01 d plus 0.05. Therefore, n is equal to, now n is equal to what will be 5v minus TL divided by 0.05 plus 0.01 d, equation 5. Now, in equation 5, here at 0.05 we want value is equal to 1. Therefore, what we have to do? We have to divide numerator and denominator by 0.05. Therefore, what is our next step? This is our next step. N is equal to 5v minus TL divided by 0.0v plus 0.01 d. Now, dividing numerator and denominator by 0.05, what will be the equation? Therefore, n is equal to 5v divided by 0.05 minus TL divided by 0.05 divided by 0.05 divided by 0.05 plus 0.01 d divided by 0.05. Therefore, n is equal to 100v minus 20 TL divided by 1 plus 0.2 d. Therefore, this is our new equation now. Therefore, comparing this equation with standard form, that is x upon y is equal to k divided by 1 plus tau d. Therefore, we are getting time constant tau is equal to and system gain k is equal to. Therefore, comparing these two equations, what we are getting? k is equal to 100V minus 20 TL and tau is equal to 0.2. Therefore, this is our problem. Now we will see next problem, that is problem number 5. Example 5. The operating curve for a DC motor is as shown in figure, where capital T is motor torque, N is speed and V is applied voltage. The reference operating point is at Ni is equal to 2000 and Ti is equal to 100. Determine the linearized equation of operation for change in torque at the reference point. The net torque at the reference point for acceleration is T minus TL is equal to J into dN by dt, where J is equal to 0.001. Determine the differential equation relating the output voltage V and load torque TL. What is the time constant of the system? Therefore, again they have told us to determine differential equation relating the output voltage V and torque TL, and they have also told us to calculate time constant, means tau. Therefore, same procedure we will use whatever we have used to solve problems number 1 to 4. Therefore, they have given us the curves. Therefore, these are the curves. Again, on y-axis torque is there 100, 200, 300. On x-axis speed is there 0. Here 0 is there, 2000, 4000. Due to interaction of torque and voltage, this voltage, torque and speed, these are the voltage lines. V is equal to 20, V is equal to 40 and V is equal to 60. Now we will determine the differential equation. Therefore, solution. They have told us to determine T approximate, then time constant tau. Here the non-linear function is, that is torque is a function of speed and voltage. So the generalized linear equation form is small t is equal to C1 into small n plus C2 into small v, equation 1. Now we will determine values of C1 and C2 as that of the earlier problems from the graph. Therefore, once again, these are the graphs, whatever it is given in the problem. Therefore, what is the value of C1? C1 is equal to dou t divided by dou n, when V is equal to constant. What is constant value of V? That is mean value of the voltage, 40. Therefore, along this line BC, we will find out dou t and dou n. Therefore, C1 is equal to again delta t upon delta n, when V is equal to constant. Therefore, C1 is equal to, what is this mean value of voltage? 40. Therefore, along this line BC, we will find out delta t and delta n. Therefore, C1 is equal to TB minus TC divided by NB minus NC, which is equal to 200 minus 0 divided by 0 minus 4000, which is equal to minus 0.05. Therefore, again C2 is equal to dou t divided by dou v, when n is equal to constant, which is equal to delta t upon delta v, when n is equal to constant. Therefore, what is constant value of n? 2000, or mean value of n. Therefore, this DE line is the mean line or constant line. Therefore, along this line we will find out delta t and delta v. Therefore, C2 is equal to TD minus TE divided by VD minus VE, which is equal to TD means 200, TE means 0, VD means 60, VE means 20. Therefore, C2 is equal to 200 minus 0 divided by 60 minus 20 is equal to 5. Therefore, our equation 1 becomes small t is equal to minus 0.05 n plus 5 v, equation 2. Now next, T approximate is equal to Ti plus small t. Therefore, T approximate is equal to 100. This Ti is equal to 100. This is, we have taken this value from the graph. Ti means mean torque or constant torque. Therefore, 100 minus 0.05 n plus 5v, equation 3. Now next, they have given us this equation. T minus TL is equal to J into dN by dt, where J is equal to 0.001. Therefore, substituting this value of J here, therefore T minus TL is equal to 0.001 dN, because d by dt is nothing but capital D. Therefore, small t is equal to 0.001 dN plus TL, equation 4. Now we will compare equation 2 and equation 4. Therefore, next, equating equations 2 and 4, this is our equation 2, small t is equal to minus 0.05 n plus 5v, equation 4, small t is equal to 0.001 dn plus tl, equation 4. Therefore, compare these two equations. We are having minus 0.05 n plus 5v is equal to 0.001 dn plus tl, which is equal to 5v minus TL is equal to 0.001 dn plus 0.05 n. Terms related to n we have taken on one side. Therefore, 5v minus TL is equal to small n into bracket 0.001 d plus 0.05. Therefore, n is equal to 5v minus TL divided by 0.05 plus 0.001 d, equation 5. Now here we want value is 1. Therefore, we will take common 0.05, or we will divide numerator and denominator by 0.05. Therefore, n is equal to 5v minus TL divided by 0.05 plus 0.001 d. Therefore, which is equal to 5v divided by 0.05 minus TL divided by 0.05 divided by 0.05 divided by 0.05 plus 0.001 d divided by 0.05. Therefore, n is equal to 100v minus 20 TL divided by 1 plus 0.02 d. Now we will compare this equation, that is n is equal to 100v minus 20 TL divided by 1 plus 0.02 d with standard form of the equation. That is, what is the standard form? This is our standard form of the equation. X divided by y is equal to k divided by 1 plus tau d. Therefore, we are getting time constant tau is equal to 0.02. Therefore, this is our end of the problem number 5. Now, we will see last problem, that is problem number 6. Then this chapter will over. Now, example 6. The characteristics of engine are described by the family of curves shown in figure. Determine the linear approximation for torque T produced by the engine, and load torque of the engine TL is given by T minus TL is equal to J into dN by dt plus Bn, where J is equal to 0.02 and B is equal to 0.03. Determine the differential equation for the given condition relating the change in speed n to the change in fuel flow q and change in load torque TL. Determine the time constant tau and steady state system gain for given operating condition for the system. Therefore, this is the problem, and they have provided these curves. Therefore, from this curve we are getting on y-axis change in fuel flow Q, values are 75, 100, 125. On x-axis values of speed are 800, 1000, 1200, and interaction of this is nothing but torque. Torque T is equal to 40, torque T is equal to 50, torque T is equal to 60. Now from this graph, what is Ti, Ti is equal to 50 or mean value of the torque. T is equal to 50. What is Ni or mean value of speed? Ni is equal to 1000 or constant speed N is equal to 1000. What is change in fuel flow? Q is equal to, what is Qi? What is Q constant or Qi or mean value of fuel flow? That is Q is equal to 100. Therefore, these three values you have to remember: 100, 1000 and 50. Therefore, once again, we have to draw the graph. That is, we have to first to determine T approximate, then second time constant tau, and third system gain K. Here, the non-linear function can be torque is a function of speed and fuel flow, that is T is a function of NQ. So, generalize the linear form of equation is small t is equal to C1n plus C2q, equation 1. Therefore, we will find out values of C1 and C2 from the graph. Therefore, these are the graphs they have provided to us. This is our equation 1. Small t is equal to C1n plus C2q. We will find out values of C1 and C2 from the graph. Therefore, C1 is equal to dou t divided by dou n when q is equal to constant, which is equal to delta t divided by delta n when q is equal to constant. What is constant value of q? Q is equal to 100. This is the constant value of q. Therefore, along this line BC, we will find out change in torque and change in speed. Therefore, C1 is equal to TB. C1 is equal to TB, that is line passing from the point B, TB minus TC divided by NB minus NC, which is equal to, what is TB? TB is equal to 60, TC is equal to 40. What is NB? NB is equal to 800 and NC is equal to 1200. Therefore, C1 is equal to 60 minus 40 divided by 800 minus 1200, which is equal to minus 0.05. Now we will find out value of C2. Therefore, C2 is equal to dou t by dou q. Dou t by dou q when n is equal to constant, which is equal to delta t upon delta q when n is equal to constant. What is constant value of n? Constant value of n is equal 1000. Therefore, along this line ED, we will find out delta t and delta q. Therefore, C2 is equal to delta t. What is delta t? That is TD minus TE divided by QD minus QE, that is delta Q, which is equal to, what is TD? TD is equal to 40, TE is equal to 60. What is QD? QD is equal to 75, QE is equal to 125. Therefore, C2 is equal to 40 minus 60 divided by 75 minus 125, which is equal to 0.4. Therefore, substituting values of C1 and C2 in equation 1, we get small t is equal to minus 0.05 n plus 0.4 q, equation 2. Therefore, we will find out T approximate. Therefore, T approximate is equal to Ti plus small t. Therefore, T approximate is equal to 50 minus 0.05 n plus 0.4 q, equation 3. This 50 value we have taken from the graph, that is constant value of the torque or mean value of the torque. Now they have given us another equation, that is T minus TL is equal to J into dN by dt plus Bn. They have given us values of J and B, that is J is equal to 0.02, B is equal to 0.03. Therefore, substituting these values, T minus TL is equal to 0.01 dN plus 0.03 N. Therefore, T is equal to N into bracket 0.02 D plus 0.03 plus TL, equation 4. Now we will compare equation 2 and equation 4. Therefore, T is equal to minus 0.05 N plus 0.4 Q, equation 2. Again t is equal to n into bracket 0.02d plus 0.03 plus tl, equation 4. Therefore comparing these two equations, minus 0.05n plus 0.4q is equal to n into bracket 0.02d plus 0.03 plus tl. Therefore 0.4q minus tl is equal to n into bracket 0.02d plus 0.03 plus 0.05. Therefore 0.4q minus tl is equal to n into bracket 0.02d plus 0.08. Therefore n is equal to 0.4q minus tl divided by 0.08 plus 0.02d, equation 5. Now here we want value is equal to 1. Therefore we will divide numerator and denominator of equation 5 by 0.08. Therefore n is equal to, this is our equation 5, 0.4q minus tl divided by 0.08 plus 0.02d. Therefore n is equal to 0.4q divided by 0.08 minus tl divided by 0.08 divided by 0.08 divided by 0.08 plus 0.02d divided by 0.08. Therefore n is equal to 5q minus 12.5 tl divided by 1 plus 0.25d. Now we will compare this equation with the standard form. What is our standard form? X divided by y is equal to k divided by 1 plus tau d, where k is equal to system gain and tau is equal to time constant. Therefore comparing this equation A with this equation, therefore what is our equation? Therefore k is equal to 5q minus 12.5 tl and tau is equal to 0.25. Therefore this is our end of the problem number 6 and end of this chapter number 2. Thank you very much. All the students should solve these problems, then and then you will understand. Thank you very much.